We will discuss the numerical of first chapter, that is moment of force or torque. So let's see the first numerical. In first numerical they are saying the moment of force of 10 Newton. So this is F. About a fixed point O is 5 Newton meter. Newton meter is the unit of moment of force. So this is moment of force, this is force. Calculate the distance of the point O from the line of action. So R you have to calculate. So formula is moment of force is equal to force into perpendicular distance of force from the point O. So moment of force F into R. Moment of force is 5 Newton meter and force is 10 into R. So R is equal to 5 by 10, that is 0.5 meter. Let's see the second numerical. In second question, a net is opened by a wrench of length 10 centimeter. So this is R. Given in centimeter, you may change into meter. If the least force required is 5 Newton, this is F. Find the moment of force. So moment of force F into R. See. Length, that is 10 centimeter, convert into meter will become 0.1 meter. Force is given 5 Newton. So moment of force F into R. Keep reminding to write the formula is very important. It carries 1 marks. F is 5, R is 0.1. Then the answer will become 0.5 Newton meter. Newton meter is the SI unit of moment of force. Now third number. A wheel of this diameter 2 meter. So diameter of this wheel is A to B, that is 2 meter. Is shown in this figure with the axle at O. O is the axis of rotation, you may say. If a force F is equal to 2 Newton is applied at B. On B we are going to apply a force of 2 Newton. In the direction shown in the figure. The direction of the force is this. Calculate the moment of force about number 1 center means about this. So the force is acting at B. So the first part you have to calculate the moment of force about O. So the distance from O to B will be half of this distance, that is 1 meter. And second, at point A, means if the point of rotation is at A, then the distance will be AB, that is equal to 2 meter. Now how to solve this problem? Let's see. So force is given 2 Newton, diameter is 2 meter. So perpendicular distance between B and O, that is 1 meter, half of the diameter. This is 2 meter, so this is 1 meter. So moment of force at O, at point O. So that is F into R, that is 2 into 1, that is 2 Newton meter. And the wheel will rotate clockwise according to the direction of clock. Now the second, if we are carrying the moment of force about A, then the moment of force at point A, that is equal to F into R. F, that is 2 Newton. Now the R will be this distance, and this distance is diameter, that is 2. So 2 into 2, that is 4 Newton meter, that is also clockwise. Now see the fourth question. In fourth question, in this diagram shows two forces F1, that is 5 Newton, and F2 is 3 Newton. This is F1 acting towards down. This is F2 that is also acting towards down. Acting at a point A and B of the rod pivoted at the point. This is the point of pivotation, such that OA is equal to 2 Newton and OB is equal to 4 Newton. Now what do you have to calculate? Number 1, moment of force F1 about O. So you have to calculate the moment of force F1 about O, that is 5 into 2, 10 Newton meter anti-clockwise. Moment of force F2 about O, F2 is this, about O, that is 3 into 4, 12 Newton meter clockwise. Total moment of force of two forces about O. So clockwise moment and anti-clockwise moment, both are opposite in direction. Let's see the solution. So first, moment of force F1 at a point about point O, that is equal to 5 into 2, that is 10 Newton meter, as I have told you, anti-clockwise. Moment of force F2, that is 3 Newton at B about the point O. So from the distance of B from O, that is 4 meters, so 3 into 4, that is 12 Newton meter, that is clockwise. One is anti-clockwise, other is clockwise. Then the total moment of force will be subtracted. Bigger one minus smaller one. So bigger one is clockwise, so that is 12 minus anti-clockwise, that is 10. So the total moment of force will become 2 Newton meter clockwise. Let's see the question number 5. Two forces each of magnitude 10 Newton act vertically upward and downwards respectively. Two ends of the uniform rod of length 4 meter, which is pivoted at its midpoint as shown, 1.3 diameter. Determine the magnitude of the resultant moment of force about the pivoted O. This is the point of pivot. Both forces are equal but acting opposite direction. This will create clockwise moment, this will also create clockwise moment. So what do you have to find out? You have to find out the total moment of force. So let's see, given AB, let this is A, this is B. So AB is equal to 4 meter, hence OA is equal to 2 meter and OB is equal to 2 meter. Moment of force F 10 Newton at A about the point O will be equal to F into OA, that is 10 into 2, that is 20 Newton meter clockwise. Similarly, moment of force F 10 Newton at point B about the point O, that is equal to F into OB, that is 10 into 2, that is 20 Newton meter clockwise. It is clockwise, this is also clockwise. If both are clockwise or both are anti-clockwise, then the total moment of force will be added. So the total moment of force about the midpoint will be 20 plus 20, that is 40 Newton meter clockwise. Now the question number 6. In this figure 1.35, this is a diagram shown. Two forces each of magnitude 10 Newton. A force acting at A, that is of 10 Newton, a force acting on B, that is of also 10 Newton. Acting on the point A and B at the separation of 50 centimeter. The total distance from these two line of action, that is 50 centimeter. Opposite direction. Calculate the resultant moment of two forces about the point A, about the point B and about the point O situated exactly at the midpoint. Means the distance, this will be half of this. If it is 50 centimeter, that is 25 centimeter, that is 25 centimeter. See. Number 1. Perpendicular distance of point A from the force F. The perpendicular distance of point A from the force F 10 Newton at B is 0.5 centimeter. Means the force acting at A, the distance of this force from B, that is equal to 5 centimeter, and the distance of this force from A, that is 0. Now, so 10 into 0.5, that is equal to 5 Newton meter clockwise. Hence the moment of force about A, that is 10 into 0.5, that is 5 Newton meter clockwise. Perpendicular distance of point B from the force F 10 Newton at A, that is 0.5 meter, while it is 0 from the force F 10 Newton at B. Let's see this from the diagram. Means that perpendicular distance of force acting at B from A, that is 50 centimeter or 0.5 meter, and the force acting at B, the distance from point B, that is 0. So net moment of force will become, hence the moment of force about B, that is 10 into 0.5, that is 5 Newton meter clockwise. Now perpendicular distance of point O from the either of the forces F, that is 10 Newton, is 0.25 meter. So moment of force F 10 Newton at A about O, that is 10 into 0.25 meter, that is equal to 2.5 Newton. And similarly from the B, that is also 2.5 Newton meter. So total moment of force both are creating clockwise, that is 2.5 plus 2.5, that is 5 Newton meter. Question number 7. A steering of diameter 0.5 meter is rotated anti-clockwise by applying two forces each of magnitude 5 Newton. Draw the diagram. So first you have to draw this diagram. So steering, it is in circular in shape. Draw a circle. Then anti-clockwise. So from the right side you have to draw a force line upward like this, and from this end you have to draw a force line towards down. So it will create anti-clockwise moment. Draw the diagram to show the application of forces and calculate the moment of couple applied. So 1 marks will be for this diagram. Now you have to find out the total moment of couple. So moment of couple is, what is couple? If two equal and opposite force acts on a body, they form couple. So how to find out the moment of couple? Either of force, any one of force, into perpendicular distance from the line of action. Means from this to this distance. Now moment of couple, either of force into couple arm. So force is 5 Newton and couple arm diameter, whether it is this like this, that is 0.5 meter, so it will become 2.5 Newton meter. Now question number 8. A uniform meter rule is pivoted at its midpoint. Meter rule length is 100 centimeter. The weight of the meter rule acts at its midpoint, that is 50 centimeter. A weight of 50 gram force is suspended at one end of it. Where should a weight of 100 gram force be suspended to keep the rule horizontal? So means a weight of 50 gram force acts at the one end, and from the other end, at what distance from the point of pivot 100 gram force should be kept so that the meter rule become horizontal. Suppose that let the 50 gram force weight produce anti-clockwise moment about the midpoint of the meter rule. Because it is kept at one end, so distance of 50 gram force from the midpoint, that will be 50 centimeter. Let the weight of 100 gram force produce the clockwise moment, means 50 gram force is kept in this side to the meter rule and the 100 gram force is kept to this side of the pivoted point. About the midpoint, let its distance from the middle be d, means from the point of pivot the distance of 100 gram force is d. So from the formula you have to write according to the principle of moment. Anti-clockwise moment is equal to clockwise moment. You have to write this line. Then anti-clockwise moment will be created by 50 gram force. 50 gram force into 50, that is the distance from the point of pivot. 100 gram force distance you have to calculate into d. So d will be equal to 50 into 50 upon 100, so that is equal to 25 centimeter from the other end. Means the 100 gram force must be kept 25 centimeter from the point of pivot. Now question number 9. See, a uniform meter rule balanced horizontally on a knife edge placed at a 58 centimeter, means the point of pivot is at 58 centimeter mark. When a weight of 20 gram force is suspended from one end. Draw a diagram. Keep reminding that the point of pivot is not at a center, it is at 58 centimeter. This is 100 centimeter meter rule. Point of pivot is at 50 centimeter. Weight of the rule will act at the center, that is 50 centimeter. Means the weight of the rule will create anti-clockwise moment. So we have to put this 20 gram force weight to the right side of the meter at one end. So you have to calculate if it is balanced, what is the weight of the meter. So first of all, draw the diagram of the arrangement. 1 marks for this diagram. You have to mark 0, 50, 58, 100 centimeter mark, 20 GF and mg. Now, what is the weight of the rule? Means mg you have to calculate, or either mg you may write w. So weight mg, that is w of the rule, produce an anti-clockwise moment about the knife edge O. In order to balance it, 20 GF force be suspended at the end B to provide clockwise moment about the knife edge O. See, from the principle of moment, anti-clockwise moment is equal to clockwise moment. Anti-clockwise moment will create this width. So that is W into this distance, that is 8. 58 minus 50, that is 8. Now, clockwise moment will create this width. So 20 GF into this distance, 100 minus 58, that is 42. So you have to calculate W. So W is equal to 20 into 42 divided by 8. So this will become 105 gram force. Important question. Now question number 10. The diagram below shows a uniform bar supported at the midpoint O. So midpoint is this. A weight of 40 gram force is placed at this distance 40 centimeter. Means from the point of pivot the weight distance is 40 centimeter. To the left of the point O, how can you balance the bar with the weight of 80 gram force? Means at what distance 80 gram force be placed so that this bar be balanced. So 80 gram force will be kept from this side to this side from the point of pivot. But at what distance, that you have to calculate. See, we know very well that 40 gram force will create anti-clockwise moment. So 40 and the distance that is 40. So 40 and 40 that is equal to 1600 gram force centimeter. Clockwise moment will be created by the 80 gram force. The distance we do not know, that is d. So from the principle anti-clockwise moment is equal to clockwise moment, that is equal to 40 into 40 is equal to 80 into d. So d is equal to, that is 20 centimeter to the right of the point. Means where the 80 gram force weight will be kept, means 20 centimeter from the point of pivot. Means at this point if 80 gram force weight is placed, then the meter rule will be at equilibrium. See question number 11. In this question, shows a uniform meter rule placed on a fulcrum at its midpoint O and having a weight of 40 GF at 10 centimeter mark. So a 40 GF weight is placed at 10 centimeter mark. So this distance will be 50 minus 10, that is 40. Then and the weight of 20 GF at 90 centimeter mark. 20 GF will create clockwise moment. It is placed at 90 centimeter mark. So this distance is equal to 90 minus 50, that is 40. Is the meter rule in equilibrium? If not, how will the rule turn? So first of all, you have to calculate anti-clockwise moment and then clockwise moment. If both are equal, then the meter rule will be at equilibrium. If both are not equal, then meter rule will not at equilibrium. Then see the solution. Anti-clockwise moment created by the 40 GF, 40 into 50 minus 10, that is 40. So that is 1600 gram force centimeter. This is CGS unit of moment of force. Clockwise moment will be created by 20 GF. So clockwise moment is equal to 20 GF into 90 minus 50, that is 40. So that is 800 gram force centimeter. See, anti-clockwise moment is 1600 gram force centimeter and clockwise moment is 800 gram force centimeter. Because anti-clockwise moment is greater than clockwise moment, then the meter rule will try to rotate anti-clockwise. So, anti-clockwise moment is not equal to the clockwise moment, hence the meter rule is not in equilibrium and it will turn anti-clockwise. Now the second part, to balance it. See the second part. How can the rule be brought in equilibrium by using an additional weight of 40 GF? Because this moment is greater, so this 40 GF must be placed to this side, anywhere from the point of pivot to balance the rod. Let's see. To balance it, 40 GF weight should be kept on the right hand side so as to produce a clockwise moment about the middle point. Let its distance from the middle be d. Means from the point of rotation, the distance of 40 GF be d. Then the clockwise moment will be equal to 20 GF into 40 plus 40 GF into d. And anti-clockwise moment, that is equal to 40 GF into 40. So anti-clockwise moment is this, clockwise moment is this, you have to keep here. Then 40 into 40, 1600 and 20 into 40, that is 800, bring to this side, that is 800. So 1600 minus 800, 800 will left. Here 40 into d. So d is equal to 800 divided by 40, that is 20 centimeter on the other side. Hence, by placing the additional weight of 40 GF at 70 centimeter mark. Let's see the mark.